Okay, in this situation, we know the volume of a cylinder is 400 cubic centimeters. That could happen a lot of different ways. We need to figure out the way that minimizes the amount of material used to create that cylinder, or in other words, minimize our surface area. Okay? Surface area of a cylinder can be found by adding the areas of all three surfaces together. So you got the top circle, which is pi r squared. You got the bottom circle, which is another pi r squared. So that actually makes 2 pi r squared. Okay? But then you got the area of the side of the cylinder. Well, the area of the side of a cylinder is a rectangle. So you got a cylinder that looks something like this. The sides of the cylinder create a rectangle. The height of the rectangle is the height of the cylinder. The length right here of the rectangle is the circumference of the top circle. Circumference is 2 pi r. So 2 pi r times h would give you the surface area formula for a cylinder. Okay? So we need to figure out what r and what h to use to minimize our surface area. Well, having two variables in here makes it tough to figure out what makes a minimum. The fact that they told us the volume was 400 cubic centimeters helps us do a little bit of some math and some substitution. Okay? We know that pi r squared h has to equal 400 because that's the formula for volume. And we know our volume is definitely set at 400 cubic centimeters. We could solve this equation for h, so divide both sides by pi r squared. So now h equals 400 divided by pi r squared. And the reason I'm going to do that is because now I can take this and substitute it in for this h right up here, and then I have my entire surface area equation using only the variable r. Does that make some sense?
Yeah.
So I have 2 pi r squared plus 2 pi r, and then in place of the h, I'm writing 400 over pi r squared, right?
Right.
Okay, I'm going to simplify it because it does simplify pretty nicely. The 2 times the 400 makes 800. The pi's will cancel out. This r will cancel one of those r's, and I'll just be left with 800 over r. Okay? So there's my equation for surface area for this particular problem. Okay? So, we know the volume is 400 cubic centimeters. I use that fact to solve for h, and then whatever h was equal to, I substituted that in for the h in my surface area equation to get everything in terms of radius, to get everything in terms of r. And now all I need to do is figure out what radius gives me the smallest surface area possible. So this is where, if you had taken calculus, right now we do the derivative and blah blah blah, okay? But this is advanced math. This is not calculus, okay? So now what we could do, we have talked about maximums and minimums on graphs. So all you're going to do right now is you're going to graph this thing on Desmos and find a minimum. And a minimum is going to be where a graph comes down and kind of the bottom of a valley type deal.
Yeah.
Okay. So I'm going to have you enter this equation into Desmos, and I want you to find that minimum. And for speed purposes, I'm going to let you type it in, but I'm going to find it real fast, and that way I can keep the video rolling. Just use X, or that's fine.
Yeah.
Over divided by. Yep, R. No, just R.
No, just not.
See how it's
Yeah,
getting
yeah,
over.
yeah.
figure out how you, there you go. Okay, awesome. Tell me what that coordinate is right there, typical. Okay, sorry about that. What do we got?
Is 300
The coordinate.
3.993, comma 300.53.
Okay? So, what we did was we graphed this on Desmos. If you need help graphing on Desmos, you have to ask the teacher, alright? But, you should be able to graph this on Desmos. There is a minimum that occurs somewhere, okay? And it happened to be at the coordinate 3.993, comma 300.53. Okay? Well, look at your equation. The x value of the coordinate represents our radius, our r, and the y value of that coordinate represents our surface area. So we know that if this cylinder has a radius of 3.993 centimeters, it will have a surface area of 300.53 centimeters squared, and we cannot get a smaller surface area than that because that was the bottom of kind of a valley there. All the other surface areas are further up, okay? So, this is my radius I need. This is the surface area I create. And if you want to know the height needed, you just take this radius, substitute it in right here, 400 divided by pi times this squared, that'll give you the height of that cylinder as well. And that's what the question is asking. It says, what are the dimensions of the cylinder that gives you the smallest surface area? Well, we know this is the smallest surface area because all the other surface areas around it were bigger.
Yep.
And we know the radius because the way we wrote our equation, my x value represents my radius.
Yep.
So you know this, plug it in here to get that, write down the answer of your radius and your answer of your height, and that will be the answer to that question. Good?
Good.
All right.